How to master tokenization for LLMs, techniques explained. Discover essential techniques to enhance text processing efficiency with large language models, mastering skills that transform text into meaningful units. Welcome to our journey into mastering tokenization for large language models. Did you know that over 90% of the world's data is unstructured text? Tokenization is the key that unlocks this data, transforming it into something that LLMs can process efficiently. In this video, we'll explore various tokenization techniques, from basic to advanced, and demonstrate how they can significantly enhance the performance of your language models. Whether you're a seasoned data scientist or just starting out, by the end of this video, you'll be equipped with the knowledge to optimize your LLM projects. So, let's dive in. Tokenization is the process of breaking down text into smaller units, or tokens, that are easier for models to understand. Historically, tokenization has been a fundamental component of natural language processing, NLP. At its core, it involves dividing a string of text into words, phrases, or other meaningful elements. These tokens form the basis for further processing in NLP pipelines. Basic tokenization techniques include word-level tokenization, where each word is a token, and character-level tokenization, which breaks text into individual characters. These methods lay the groundwork for more sophisticated techniques, providing the initial layer of abstraction needed for effective text analysis. For LLMs, efficient tokenization means better comprehension and prediction capabilities, translating to more accurate and relevant outputs.
In the realm of tokenization, two predominant methods are word-level and subword-level tokenization. Word-level tokenization involves breaking down text into individual words, which is straightforward but often struggles with out-of-vocabulary words and inflections. This is where subword tokenization shines. Techniques like Byte Pair Encoding, BPE, and WordPiece allow for text to be segmented into smaller, more manageable pieces. This method is particularly effective in handling rare or unseen words by breaking them into known subword units. Subword tokenization not only reduces vocabulary size but also improves the model's ability to generalize across different linguistic variations, thereby enhancing the overall performance of LLMs. Byte Pair Encoding, BPE, is a popular subword tokenization technique that iteratively merges the most frequent pairs of bytes into new tokens. This process continues until a predefined vocabulary size is reached. BPE is particularly beneficial in reducing vocabulary size while maintaining the ability to handle complex linguistic structures. In practical applications, BPE has been shown to improve the efficiency and performance of LLMs by minimizing the number of out-of-vocabulary words. For instance, models like GPT-3 employ BPE to ensure a compact and effective representation of text data, allowing them to process a vast array of inputs with higher accuracy. SentencePiece is a versatile tokenization tool that offers several advantages over traditional methods. Unlike BPE, which requires pre-tokenized text, SentencePiece treats the entire input as a sequence of bytes, providing a more uniform approach to tokenization. This makes it particularly effective for multilingual texts, where diverse scripts and character sets are present. SentencePiece integrates seamlessly with popular NLP frameworks, enabling the development of more robust language models. By handling the intricacies of language more effectively, SentencePiece improves the accuracy and efficiency of LLMs, making it a valuable tool in the modern NLP toolkit. Tokenizing multilingual text presents unique challenges due to the vast array of scripts, languages, and writing systems. Each language has its own set of rules and structures, making it difficult to apply a one-size-fits-all approach. These challenges can impact the performance of LLMs, leading to inaccuracies and inefficiencies. To address these issues, strategies such as adaptive tokenization and the use of multilingual models are employed. Tools like SentencePiece and OpenNMT provide support for these strategies, enabling more effective tokenization across languages. By understanding and addressing the complexities of multilingual tokenization, we can enhance the capabilities of LLMs in handling global text data. Let's explore how top LLMs implement tokenization in real-world scenarios. GPT-3, for instance, relies heavily on byte pair encoding to manage its extensive vocabulary efficiently. This approach allows GPT-3 to handle a wide range of languages and dialects, providing accurate predictions and responses. On the other hand, BERT utilizes WordPiece tokenization, which focuses on the most informative subwords to optimize understanding. These case studies reveal that while different models may employ unique tokenization methods, the underlying goal remains consistent: to enhance the model's ability to comprehend and process text effectively. These insights offer valuable lessons for future model development, highlighting the importance of selecting the right tokenization strategy.
Integrating tokenization techniques with popular NLP frameworks can greatly streamline the development process. Frameworks like TensorFlow and PyTorch offer comprehensive support for various tokenization methods, providing pre-built modules and libraries to facilitate seamless integration. This not only simplifies the implementation of tokenization processes but also enhances model performance by leveraging the framework's optimized algorithms. By exploring practical implementation tips and examples, developers can harness the power of these frameworks to create more efficient and effective language models, ultimately leading to improved outcomes in NLP projects.
Evaluating the effectiveness of tokenization is crucial for ensuring the optimal performance of LLMs. Key metrics include vocabulary size, tokenization speed, and model accuracy. By employing tools and techniques such as cross-validation and error analysis, developers can gain valuable insights into the impact of tokenization on model performance. These evaluations often reveal areas for improvement, guiding the refinement of tokenization strategies. As the field of NLP continues to evolve, staying abreast of future trends in evaluation will be essential for maintaining the competitiveness and effectiveness of language models. As we wrap up this deep dive into tokenization for LLMs, let's recap the key techniques and insights we've covered. From understanding basic tokenization to exploring advanced methods like Byte Pair Encoding and SentencePiece, mastering these techniques is crucial for enhancing the efficiency and accuracy of your language models. We encourage you to continue exploring and experimenting with these methods in your projects. Don't forget to leave your thoughts in the comments below, and share this video with others who might benefit from it. Stay tuned for our next video, where we'll delve into more advanced NLP topics.